My name is Chase Atherton, and this is the 49er Rocketry Team Senior Design 2 Expo poster. This poster will cover everything from our full-scale vehicle design all the way to our payload, as well as some of the flight results from that vehicle. Here we have the specifications of the full-scale vehicle. The team was tasked to design and build a vehicle that is capable of reaching an altitude between 4,000 and 6,000 feet. The team decided on a target altitude of 5,000 feet, and this was achieved by using an Aerotech L1390G motor. The airframe of the vehicle was constructed from 2x2 twill weave carbon fiber. The nose cone was 3D printed out of ABS plastic. The fins were also 3D printed out of ABS plastic, but layered with carbon fiber for extra strength and durability. And finally, the boat tail on the end of the rocket was 3D printed out of Ultem 9085, which is an aerospace grade high temperature resistant filament. Above the vehicle specifications, we have a simulation that was ran to simulate the altitude reached at varying wind speed and rail cants. On the right side, we have our flight results. This is the raw data obtained from our altimeters on board the rocket. This records the altitude reached, the voltage, the temperature, as well as the pressure over the course of the flight. This year's payload was named Anvil, or Autonomous Vehicle Imaging Localization. This year's payload was tasked to determine the landing location of the vehicle on a 5,000 square foot grid system, with each grid box being no larger than 250 square feet. This all has to be done without the use of GPS, and said grid position must be transmitted wirelessly to our ground station. The camera vision code used is a custom image processing algorithm that compares pairs of images and isolates groups of similar pixels. Each of these images is compared to one another, and it allows for the determination of the landing location. Below this, the Anvil housing, you can see that we utilized a gimbal to ensure that we have stable images upon descent of the vehicle and payload. On the right side, we have our electrical design diagram, as well as some of our PCB schematics used on the payload this year. The team would like to take a moment to thank all of our sponsors and supporters from this year. North Carolina Space Grant and Averna provided the team with funding. Siemens provided the team with all of their software. We would also like to thank the College of Engineering and Dr. Kenton for all of his support throughout this competition. This concludes the Expo poster video. Thank you very much.